So section 5.2 on page 243 talks about differential operators and the elimination method. Differential operators is nothing more than you taking d dt of, say, y, and saying that's d operating on y. So replace the derivative by d, and there are shortcuts to many differential equations. For example, they say show that this operator, this is taking a derivative plus 2, derivative minus 1 times derivative of a function minus 1 is the same. You'll notice that this is foiling that. If I take d minus 1, d plus 2 in any order operating on y, that would be d minus 1. If I take, and this is nothing more than the derivative of that, plus 2 times y. And now if I take the derivative of this, that will be y double prime plus 2y prime minus 1 times that quantity. I will simply get y double prime plus y prime minus 2y. That will be the equation. We want to go this way, and eventually we want to backtrack our steps as well. Now, if I was to multiply those instead and apply the second derivative plus d minus 2 operating on y, I'll notice that's the second derivative plus the derivative minus 2y, and that's a lot quicker. We're going to use this kind of analogy in future sections, so we just want to develop a feel for it and use it a bit for systems of equations. So for example, if I look at this problem, I'm going to solve this problem two ways. By the way, this was number 2, I believe, on page 249. So this problem right here, if I wanted to solve this, one way of solving this is for me to say, you know what, let's eliminate, let's substitute, and this one you can. Let's substitute one variable for the other. That is, if I solve this equation for x, then I'll get 4x to equal y minus y prime, and x is really 1/4 y minus y prime. If I take this quantity now and put it right there and right there, so if I take a derivative of that, that is 1/4 y minus y prime equals 1/4 into y minus y prime minus y. And this will be nothing more than the constant you ignore. The derivative of y is y prime minus y double prime equals, this is 1/4 of y minus 1/4 of y prime minus y. If I clear the fractions, that will make life a lot easier for me. So I'm looking at y prime minus y double prime equals y minus y prime minus 4y. Or simply, I could say 0 equal y double prime, and if I move this over, that becomes negative 2y prime, and those will give you negative 3y. So this is a differential equation that I know how to solve. And in this case, of course, the characteristic equation to this I know is, what is it? R squared minus 2r minus 3 equal to 0. So it's r minus 3 into r plus 1 equal to 0. So I know here that y equals c sub 1 e to the 3t plus c sub 2 e to the negative t. Now I come to x, I say, okay, well, I know what x is. There's x. In this case, x will be 1/4 y c sub 1 e to the 3t plus c sub 2 e to the negative t minus y prime. Well, the derivative of that is 3 c sub 1 e to the 3t and minus, again, minus the whole derivative. Okay, let's put it this way. C sub 2 e to the negative t, that's better. So I could say x will be 1/4, and let's see, c sub 1 minus 3 is minus 2 c sub 1 e to the 3t, and if I add those, plus 2 c sub 2 e to the negative t. So I could say x is really 1/2 c sub 1 e to the 3t plus 1/2 c sub 2 e to the negative t. And that's how you'd find the solution to both of those. But if you really pay attention, you could have moved this over and said, look, this is x prime minus x equal negative, or plus y equals 0. And if I move this over, that is 4x plus y prime minus y equals 0. And you could make this system into d minus 1 operating on x plus y equals 0, and 4x plus d minus 1 operating on y equals 0. And since this is a system of equations, I could multiply, to eliminate x, I could multiply the top by a negative 4 and the bottom by a d minus 1. And what I get, negative 4 d minus 1 operating on x minus 4y equals 0. And on the bottom, I'll get 4 d minus 1 operating on x plus d minus 1 times d minus 1 is d squared minus 2d plus 1 operating on y to equal 0. And now if I add those, these cancel out. You'll notice I'll get y double prime minus 2y prime plus y minus 4y equals 0, or simply y double prime minus 2y prime minus 3y equals 0. And you notice that this is identical to what I got right there. So the goal is to really go in this direction, because then we could use linear algebra and set those. So that's how we're going to solve. We're not going to solve by the traditional method. Anyways, on the next problem, you can't separate those like we did on number 4. So if you want to solve for x, you're going to have x prime and y in terms of both of those. Right? On the bottom, you could solve for x and plug it up there, but the way we're going to do this, we're going to look at this and say, all right, let's make this x prime minus 3x plus 2y equals sine of t, and negative 4x plus y prime plus y equal negative cosine of t. So basically, move those to the left. And my system of equation becomes d minus 3 operating on x plus 2y equal the sine of t, and negative 4x plus d plus 1 operating on y equal the cosine, negative the cosine of x. And in this case, I would multiply the top by a negative 4 and the bottom, and there's no set way of doing this. I'm choosing to get rid of x first, but it's up to you. If I do that, wouldn't this become negative 4 d minus 3 operating on x minus 8y equal negative 4 sine of t? That's a t with x. On the bottom, wouldn't I get 4 times d minus 3 operating on x plus d minus 3 times d plus 1 operating on y equal the derivative minus 3 of negative cosine of t. Now, if I follow on and say, okay, if I add those cancel out, I'll get negative 8y. This right here will be the second derivative minus 2d minus 3 operating on y equals negative 4 sine of t. And if I take a derivative of this, that will become the sine of t plus 3 the cosine of t. So here I'm looking at negative 8y Operating this, that's y double prime minus 2y prime minus 3y equals negative 3 the sine of t plus 3 the cosine of t. So I have y double prime minus 2y prime minus 11y. If I didn't make any mistakes, I'll double check my work in a minute. Yep, I did find a mistake. I shouldn't have made that a negative. They already have opposite signs. So that should have been a positive, and a positive. That would have made this a positive 8y, and that would have made this a positive for the sine. So that will make this a 5. So, simple mistakes here and there. And that will be 8, that will be a 5. Not that that's going to change the answer that much. And now I know how to solve this. I know that, the homogeneous part is going to have r squared minus 2r. Take half of the middle number and square it. R minus 1 squared equals what is wrong? Why is it not working? Add 1. Yeah, that should be a plus 5. So that's a minus 5. That's a minus 4. So r equal 1 plus or minus 2i. So here I get y equals c sub 1 e to the t cosine of 2t plus c sub 2 e to the t sine of 2t. That is the complementary solution. As for the particular solution, I'm going to take y equal a the sine of t plus b the cosine of t. I need two derivatives of that. So my equation was right there. Y double prime negative a sine of t minus b the cosine of t minus twice the product of those, so that's twice a cosine of t plus 2b sine of t plus 5 times the first, a sine of t plus 5b cosine of t equals negative 3 and negative 3, and negative 3 and positive 3. So if I look at the sine of t, there's negative a plus 2b plus 5a, and if I look for the cosine of t, that's negative b minus 2a plus 5b equals negative 3 the sine of t plus 3 the cosine of t. This is 4a plus 2b, and that should equal the number in front of the sign, which is negative 3. And this should be negative 2a plus 4b. That should equal the number in front of the cosine. If I multiply the bottom by a 2, then b equals 3, so b is 3 over 10. And if you go to any of the equations, let's go to the first one right there, and you say 4a minus 3 over 5, because the 2 cancels, the 10 divides into it 3 times. And if I clear the fractions, 20a minus 3 equal negative 15. That would mean 20a equals negative 12. So a would be negative 12 divided by 20. Hopefully I didn't make a mistake. Divide by 4. Divide by 4. Negative 3/5. So in this case, I get the solution to be y equals c sub 1 e to the t cosine of t 2t plus c sub 2 e to the t sine of 2t plus a sine, so 3 over a sine negative 3 over 5. Again, if I made a mistake on this, that's how it's done. You know, it must be a simple error. Negative 3 over 5 sine of t plus 3 over 10 cosine of t. Actually, I worked this out. Let me double check the solution I have and see if it matches. Okay, I caught the mistake. This should have been a 5. So that would make all the work is the same, except here you're going to put, what did we say, a 5. So when you get to the actual equations, instead of a 3, that's a 5. That's going to change the values. That will make, so it turns out this is really 11 over 10 if you fix the mistake, and this is 7 over 10. Now that you know this, the idea is really, what do you do after that? Well, you know here that I could go back to the equation itself again. So let's make that a 5. Okay, let's use the same color. So let's fix this part. This is a 5. So when you multiply the bottom by a 2, five, 10, that's 11. So b is 11 over 10. And if I take the first equation, 4a plus 22 over, no, 2 times plus 11 over 5. So when you multiply by 5, negative 15, that stays 11. That will become 20a equal, that's a 5. So that is by 5, that's 25. That is 14. So a is actually 14 over 20, which is 7 over 10. And here they are. 14 over 20 divided by 7 over 10 and 11 over 10. Now that we get this straightened out, we have two options. Option 1, we could go to that equation again, this right here. And what we could do, we could eliminate y out of the equation and proceed. That works the same way. The good news is you get the same characteristic equation every time. Or I could take this equation and say so in general this is faster. I could say, well, but look, negative 4x equals negative y prime minus y minus cosine of t, or simply change all the signs, right? Make them all positive and divide by 4. So I could figure out what x equals by taking 1/4. Now this is not a simple task. I want the derivative of this. That is c sub 1 e to the t times cosine of 2t minus 2c sub 1 e to the t sine of 2t, the product rule, same thing here, plus c sub 2 e to the t sine of 2t plus 2c sub 2 e to the t cosine of 2t plus 7 over 10 cosine of t minus 11 over 10 sine of t. That's this. Plus y is literally what you see. Now, anytime there's an e to the t sine of t and e to the t cosine of t, this is a bit messy. So that's why I chose this problem. It's the messiest out of what we do. Anything else will work out a lot nicer. Plus a cosine of t. And pretty much you got what x equals. So x will equal, for example, if you look at this, that would be c sub 1 cosine, so e to the t cosine of t, there's c sub 1 cosine of t, 2c sub 2, another c sub 1 that makes those two, the sine of t, we have a negative 2c sub 1 plus c sub 2 plus another c sub 2 plus 7 over 10 the sine of t, and if I add those, 11 plus 10, 21 the cosine of t divided by 10, and take 1/4 of that, and that's the solution. So this is a lot quicker than the alternative, but you could go back to the equation just like you do 2 by 2, eliminate the other, and proceed. And again, the messiest is what I did. I am going to work out 2 more problems for you just to make sure that we're getting this. Okay, number 8 is next, and by now I touched on every topic. Basically, we dealt with e to the t, we dealt with cosine and sine, we dealt with exponentials, and now we're going to deal with linear. So here, if I look at those, if you want to write this out, you can, but this is really saying, I'm going to get rid of x again, just a habit. I'm going to multiply this by d minus 3, and this by d plus 1, and make one of them negative. It doesn't matter which one. Let's say that one. So the top is going to, so when I add those, that's going to cancel out. Obviously, that's the whole purpose. I'm going to get d squared minus 1 operating on y. Let's use a different color. Plus minus d minus 3. Okay, you know what? I don't know why I always do this. So I'm going to get d minus 3 into d plus 4 operating on y. And that's going to equal, let's see what's that's going to equal. If I operate d plus 1 on t, that's going to be derivative of t. You know what? Let me write it out. Might as well. And a negative d minus 3 operating on 1. That's this. So here I have y double prime minus y. This is really d squared plus d minus 12 operating on y, if I'm not mistaken. So that would be negative y double prime minus y prime plus 12y equals, and derivative of t is 1 plus t minus derivative of 1 is 0, negative and plus 3. So I have, oh, they cancel out. I have negative y prime plus 11y equals t plus 4, if I'm not mistaken. Y prime minus 11y equal negative t plus 4. All right, first order, not second order, so this is a bit quicker. I could say the complementary solution equal to 0. That's going to be r minus 11 equal to 0. Y equals c sub 1 e to the 11t. Very quick. And I could say the particular is at plus b. Take a derivative, that's a. And if you take at plus b, no, if you take y prime, which is a, minus 11 times the derivative, that should equal negative t plus 4. That means negative 11a equal negative 1. A is 1 over 11. And if you know that, then you know that a minus 11b equal a 4. 1 minus 121b equal 44. Luckily, I worked this out just to make sure, because it's always hard. That's a minus. It's always hard to come back and fix those. So that's a minus. So that would be negative 4. That would be negative 44. So if you swap those, b will be 45 divided by 121. And by doing so, I get the solution for y. Y equal c sub 1 e to the 11t plus 1 over 11t plus 45 over 121. Now here, you'll notice it's hard to solve for y. For x, I can't say let's do this x and x's, because x is going to have a derivative in it no matter how I do it. So instead of coming up with a really messy equation, here I will use the method 2. Method 1 was kind of what we did right there. We said, look, I could solve this equation for x. Or I could go back to the equation itself. I'm talking about this equation, and eliminate y out of the equation. If I do that, I'll come back to this equation one more time, and let me copy that really quick. And here I could say, well, to get rid of y, I'm going to multiply the top equation by d plus 4 and the bottom equation by d minus 1 and make one of them negative, say the bottom one. When I add those, I'm going to get d minus 3 times d plus 4, that's d squared. Now something happens here. Plus d minus 3. And the y's are going to cancel out because that's why I'm doing this. Derivative of t is 1 plus 4t. And when I apply this, that's d squared minus 1 operating on x minus d squared minus 1 operating on x. And the derivative of this, that's 0. Minus times a negative is a positive 1. So I get x double prime plus x prime minus 3x minus x double prime plus x to equal 4t plus 2. And it's not a surprise that should be a 12. There we go. I was going to say that shouldn't be a surprise, and it's not working. I'm like, wait a minute, the theory should work. That should be a 12. And that's going to give me negative 11x. So it's not a surprise that this matches this. It's always the case. So you could skip this part if you want and jump straight to, well, if this is what you got, but you're going to have to figure this part out, which is not the same. So we know already that x is going to be c sub 1 e to the 11t from what we got right there, plus, now here we're going to say let x equal at plus b. X prime is a. So if I put those together, x prime, which is a, minus 11at minus 11b, that equation is the same. It's just that the right side is different. So this means negative 11a equal 4, so a is negative 4 over 11. And if I go to the a minus 11b must equal a 2, so negative 4 over 11 minus 11b equal a 2, so that would mean negative 4 plus minus 121 equal 22b. So negative 121b equal 26. b is 26 divided by negative 121, and in this case I know that x would be a and that's the solution to the system of equations. Now if I made a simple mistake, that could happen, but there it is. Let me see in my notes. I did get that one right, but this one I got 4 over 121, not 26. I'm not sure where I went wrong, but you get the idea. And that's how this works.